cryptocurrencies, the founder of Ethereum, Vitalic Buterin.
So I guess I'll just get right into it, right? So over the last few months especially, we've been really seeing a lot of big improvements in many kinds of blockchain applications, right? So for example, just if you want to look at usability challenges, right? So usability has been this big challenge of the blockchain space for a long time. Blockchain applications tends to be very hard to use. And if he wants to just like pick one random specific example, just exchanging one token for another token using any kind of decentralized exchange, about 2 years ago you had to use this crazy complicated thing that would take 4 or 5 transactions to do anything, and it would be hard to use and it would not work a lot of the time. 2019, you're down to just enter one text box, enter another text box, and click trade. And this is just one example, but I've been seeing a much more general pattern of this blockchain applications really becoming much more pragmatic in a lot of ways and taking a lot of these steps in addressing some of their biggest usability challenges. Scalability. So I talk a lot about base layer blockchain improvements, so things like proof of stake that's part of Ethereum 2.0, things like sharding, also part of Ethereum 2.0, that can increase the scalability of a base layer blockchain quite a lot. But what people don't know is that there's techniques that you can use to greatly increase the scalability of blockchains, even as they exist today, without changing the underlying layer, using platforms that are built on top, right? So you might have heard of the Lightning Network, you might have heard of payment channels, you might have heard of Plasma. The one really interesting one recently is something called ZK Rollup. So ZK Rollup is this kind of halfway layer 2 thing that basically says we're going to do the computation off-chain, but we're going to put proofs of the computation on-chain, and we're going to put data on-chain. So we're going to put all of the different changes that happen to the data inside of the system on-chain, so that if any one actor inside of the system disappears, someone else can just come in and take their place. And ZK Rollup is a thing that has been tested, has been run on a live network, and both theoretically it can achieve 500 transactions a second, soon over 1,000. In practice, it's already reached over 100 at one point. So privacy as well, right? So with privacy, zero knowledge proofs, we've been starting to see things like these Ethereum mixers that you can use to basically send either from one account to another account without revealing the link between the two. Zcash, the cryptocurrency, has existed for a couple of years. And so basically just on all of these fronts, we've been seeing a lot of these very real improvements, right? A lot of these things that I've been talking about, that many people have been talking about as these big barriers to using this space, have just slowly but surely been becoming smaller and smaller barriers. And at this point, it's not just words about things that might happen in the future, right? We're talking about things that actually are happening already, and things of which even more will happen in the future, and much more will happen in the future. So blockchains are slowly but surely growing into actually being technologically ready for wider scale adoption. So the next question to ask is basically, what are we going to get from all of this, right? Now, we know about blockchains in their capacity as cryptocurrencies. We know about Bitcoin and Ether and how you can just use these as decentralized forms of money. We know about non-financial applications of blockchains, but there's other things that we can do too, right? So first, let's just look at some of the non-financial use cases. So this is something called OpenCerts. It's this project based in Singapore, and the basic idea here is it's using the Ethereum blockchain to verify things like university degrees and other kinds of certificates. So basically just storing the data on the chain, and so if you want to check if a certificate is valid, you would scan through the blockchain and basically check whether or not the certificate has been published and whether or not it has been revoked. And if the certificate is still valid, then you accept the certificate, and if it's not valid, then you won't accept it. right? And this is something that a fairly large number of real universities and other institutions actually are starting to sign up for. So this is one example. Another example is something like ENS, right? So ENS is a blockchain-based domain name system. So basically, the idea here is like when on your computer you would access some new website. So if, let's say, you access like Google.com or Ethereum.org, there exist these servers that basically maintain this phone book that says, for this particular domain, like for Ethereum.org or for Google.com or for whatever else, what are the servers that you should talk to get the actual website? And right now, these phone books are kind of completely centralized. ENS is this alternative that basically takes that phone book and instead makes a decentralized blockchain-based alternative. Now, it's not just about domains for the internet. You can also use this to represent names in many other contexts, right? So for example, if you have an Ethereum address, then instead of giving people this complicated string of 42 numbers and letters, you can just register it on ENS and you can give people Vitalic.eth. And this is something that already is providing quite a lot of value to Ethereum users. And it is an application which uses and like really shows some of the value of a blockchain. But let's look at ENS a bit closer, right? So if you look at ENS a bit closer, then you can see that it's this kind of considerably more intricate and complicated system that has a lot of this internal business logic to it, right? So in this ENS decentralized domain system, like if you want to register Vitalic.eth, then step one, you register a domain, and for that you basically have to send a transaction that makes a call in a smart contract, which is this computer program that's running on the Ethereum blockchain. You register a domain, then you have the domain. If you have a domain, you have the right to set records. So if you own Vitalic.eth, you have the ability to send another type of transaction that also talks to this computer program on the Ethereum blockchain. And this other type of transaction basically says, I want Vitalic.eth to now point to this thing. And that's something that the ENS system lets you do, right? If you have Vitalic.eth, you can make it points to a website, you can make it points to an Ethereum address, you can make it points to many things. If you have a domain, you also have the ability to transfer a domain. If you have a domain, you have to pay an annual fee. If you pay it, you keep it. If you don't pay it, then the domain expires. So there's a lot of this kind of complicated internal logic inside of the system that's written in the smart contracts code, written in this computer code that's executed on the Ethereum blockchain that actually kind of executes the rules for how the ENS system runs. Let's look at another example. So DAICOs. So this is an idea that I came up with about 1.5 years ago. And the idea behind DAICOs is to basically use the blockchain to solve what was then one of the bigger problems of the blockchain space, which is just totally misaligned incentives in the ICO space, right? So in the blockchain space, we like talking about decentralization, we like talking about these kind of lofty ideas that you can build applications where you don't have to trust as many people. But then in a lot of cases, when you look at the companies that are actually launching these projects and the way that they're funded, it's completely trusted, it's completely centralized, right? Like you have a team that says, we're going to build a thing, please give us $30 million. Okay, you've given us $30 million, now you have to trust us to build the thing. So DAICOs are there to create an alternative. And the alternative basically is, instead of sending the $30 million to the developers, the people collecting the money immediately, you send the money into a smart contract. And the money only ends up going to the developers over time, right? So it might start off being $1 a second, it could be $5 a second, could be a few cents a second, could be some number of dollars, some number of ether per day. The rules could be whatever you want. And the people who participated in the DAICO have the ability to vote to increase the rate at which the developers get money. Or if they're not happy, they also have the ability to vote to shut the whole thing down and give themselves the rest of their money back. So basically the idea is to have kind of more accountability, more control at the beginning stages so that the developers have more of an incentive to actually do what they were supposed to do. So let's look at DAICOs a little closer, right? So inside of a DAICO, you actually have this kind of pretty complicated logic once again. So you have this computer program, and when you participate in a DAICO, you are sending money to a computer program, and this smart contract on the Ethereum blockchain is collecting the money. When you send money to it, you also receive tokens. If you have tokens, you have logic that allows you to transfer tokens, because that's what a token is, you can transfer it. And that logic itself is also part of the smart contract. If you have tokens, you have the ability to vote on how much money the developers can get every second or every month. And you also have the ability to vote to shut the whole thing down, right? So this is kind of how the mechanism and how the rules work, but all of these rules have to be kind of implemented in code so that they can be automatically executed. So more generally, right, if we look at these use cases, it's not just blockchains as money, and it's also not just blockchains for just verifying things. It's blockchains as a platform for designing and implementing and executing the logic of new kinds of institutions, right? So what is an institution, first of all? So governments, courts, corporations, universities, cultural practices, the institution of marriage, but basically kind of standardized patterns of behavior involving groups of people, right? And when you have what these kind of standardized patterns involving groups of people that are useful to people and that happen over and over again, it usually makes sense to develop infrastructure around them, infrastructure to help make them happen more efficiently and to help ensure that these interactions happen in the way that they're supposed to happen, in the way that people agree and expect that things will happen. So institutions can be useful for a lot of things, right? So they can help people collaborate to provide services for people, to provide services for communities, manage common resources, encourage the production of public goods, provide incentives to encourage the production of projects that benefit very large groups of people that one person can't do by themselves, and at the same time solve this kind of important problem of actually figuring out like which projects are public goods worth funding, which ones are good, which ones are bad, which ones aren't real public goods, which ones are just a pet project of one person. So there exist institutions in the real world for doing a lot of these things, right? And blockchains are interesting because they can really help kind of democratize the ability to design and experiment with and actually implement and use new kinds of institutions. So blockchains can help by encoding the rules of these kinds of institutions. So in the case of a DAICO, for example, smart contracts on the Ethereum blockchain can encode the rules for how the money gets received, how the money gets sent, who gets to vote, what are the conditions for this voting. In the case of the ENS system, the blockchain encodes the rules for who owns a particular domain at some time, what are the conditions for registering one, what are the conditions under which you lose one. Blockchains can also help kind of put objects of digital value, which could be cryptocurrency, it could be other things, directly under the control of those rules. So you can have one of these smart contracts that isn't just like a thing that exists that just tells people what should happen. It actually, by controlling digital assets, makes the thing happen directly, right? So there was this kind of analogy that was made early on in the days of smart contracts, that a smart contract is kind of like a digital vending machine, right? So a vending machine is also kind of a simple tool for encoding the rules of an institution. A vending machine just has this simple rule that says, you put $1 in, bottle of water comes out. You don't put a $1 in, bottle of water doesn't come out. And basically, vending machines can help make the process more automated, and they can help just guaranteeing that it gets executed correctly, and you don't need to have this extra human in the loop that you need to trust. So blockchains can also kind of help reduce costs, improve reliability, and just improve guarantees that the thing that will happen is the thing that people agree will happen. And they can do that in, I think, a lot more cases than many people are appreciating. Now, blockchains are not the only kind of piece of the puzzle here, right? So a lot of the time, for example, when designing institutions, you need to have some level of privacy, right? So a lot of the time there is this complicated duality where you need transparency, but you also need privacy. And usually, like, it's not that one is always good and the other is always bad, or the other is always good and one is always bad. It's often this kind of complicated balance between the two, right? So if you look at a voting system, for example, you need transparency in what the rules are, how the rules actually get enforced. You need transparency about what the process is so that people will trust it. But you also need privacy, right? You need privacy of what you voted for, and you need this really strong level of privacy that basically says, if you voted for someone, you can't prove to someone else how you voted, even if you want to. And the reason you need this strong level of privacy is because if it did not exist, then basically most people would just end up selling their votes to the highest bidder. And if you do that, then the equilibrium is the whole thing will just break until a company just ends up buying the government, and it will be all that expensive for them. So there's a lot of these sort of cases where you also want to have not just correctness of execution properties, but also these privacy properties. Blockchains are terrible at providing privacy by themselves because they're so transparent, they're so open, everything is public, everything is provable. But blockchains can be combined with cryptographic techniques to provide different levels of privacy. And this is a big part of the reason why I think a lot of this recent push for integrating stronger levels of cryptography, things like zero-knowledge proofs, making them more usable on top of the Ethereum blockchain is really great. Right, like first of all, people should be able to just have multiple accounts on the blockchain for interacting with different applications without the entire world kind of seeing what the links between those different accounts are. But also there's just this large class of applications that just needs some level of privacy inside of it to be able to kind of function correctly at all. And this is something that, once again, there's a lot of people working on, and recently there's been a huge amount of progress on, right? So these things are all happening, and there is a lot of very interesting research happening around a lot of these areas, and a lot of interesting work on implementation. So there's been a lot of interest in making these decentralized autonomous organizations, these kind of smart contract-based alternatives to traditional things like companies and in some cases nonprofits and charities. There's been a lot of interest in kind of using and coming up with different designs to run different kinds of public infrastructure, and blockchains could be a place where all or maybe some of the business logic for these applications happens. So there's been recently more and more work on actually experimenting and actually building these things. And it's really feeling like the technology finally is there for these experiments to really bear fruit and really turn into something interesting. So why aren't we there yet? I mean, the answer before was basically no privacy technology, terrible scalability, terrible usability, terrible security. But all of these things are quickly improving, right? All of these problems with blockchains are problems that are very quickly being solved, and it's not just people talking about solutions, it's more and more solutions that are actually happening. And so with all of these building blocks, a lot more of these really interesting blockchain applications that can create, really give us kind of fundamentally new ways of cooperating in this very broad sense can finally happen, and that's great. So this is all, and this is like one part of the blockchain space that like it's not something that's as easy to kind of just get excited about as and start participating in as an individual, because it's not like money where it's something that you can just go off and do and spend your money by yourself. These are kinds of applications that depend more on entire communities of people collaborating around them, but it is something that is happening more and more, and it's something that I encourage people to look into more if they're interested. So, thank you.